Hello class, these are our I am Algebra 1 Illustrative Math Algebra 1 notes for section 4-9. And today we are comparing graphs. So I have two graphs here. It says they are the graphs C and T, which give population in millions of California and Texas. So California is our blue graph, Texas is our red graph on your paper. It's just going to show as a solid line and a dashed line. So what can we tell about the population? How can we tell it, and how can we do that with function notation? So I really like, we're going to take these statements, we're going to be looking at what on the graph is going to show us that, and then just the proper way we would write that out in function notation. So I think this is really powerful today. So the first statement says in the early 1900s. So your book actually is referring to exactly 1900 when they say that, which is kind of interesting. I always think of early 1900s as like 1900, 1910, 1920, but they're going to talk about exactly 1900. California had a smaller population than Texas. So if I look at 1900 specifically, the California line is down here and the Texas line is above that. So yes, we can tell that because the graph of C is below T. So remember, our height is our population. So the higher your y value is, then the higher the population. So graph of C is below T. And I don't know why I wrote in H just now. So let's fix that and make that a T. So C is below T. Oh, because I was thinking height, that's why. How can we convey this in function notation? So C of 1900, so that would be my population of California in 1900. 1900 is my input, population is my output, would be less than the Texas population in 1900. And it's kind of nice to write them this way because I honestly can't really tell what they are. Maybe Texas is like a 3 and California is a 2. Like, it's really hard to tell from this. So around 1935, the two states had the same population of 5 million people. So sure enough, if I'm looking at 1935, right here between 1930 and 1940, both graphs are right there at 5 million people. So how we can tell that is our graphs intersect, or they cross, right? But they are intersecting, so they must both have the same population. So what's that showing us here is that C of 1935 equals T of 1935, which equals 5, right? So they're both equal to each other and they're equal to 5. On the next one, it says, and I just keep kind of shrinking this because we really want to be able to look at the graph and answer these questions at the same time. So after 1935, so that's going to be this way on my graph, right? So when I'm looking past this line, what's going on? So it says California has had more people than Texas. And look, that blue line is now, or in my case, the solid line, I think yours it's solid and dashed, is below the Texas line. So C is above T. Graph of C is above T. And so I would say C of X. So I can't just give 1 year, right? Because I'm talking about after 1935. So C of X is greater than T of X. So my output for Texas is bigger than my output, or sorry, my output for California is bigger than my output for Texas for X greater than 1935. All right. And then let's see for the next one. Both populations have increased over time with no periods of decline. So we can definitely see that. California starts here. The population is it's never like going up and then back down, right? It's always just going up. So that tells me that it's always increasing. Same thing with T. T is always going up. It's not going up and then back down. That would be bad. So in both cases, they're both increasing. This is one where even your book didn't really know how we would put that in function notation. So I'm just going to say something here for both graphs go up. Both graphs go up. Even though I don't have a way to say it in function notation, I could make it sound a little bit more mathy. I could say like c of x is always increasing, right? I could say something like that. So it's not function notation, but it's definitely the word increasing is better than the graph going up, right? But it's good for us to understand both of those things. I think graph goes up makes a lot of sense, but always increasing is really describing what's going on. So from 1900 to 1910, the population of California has risen faster than that of Texas. California had a greater average rate of change. So let's see about that. From 1900, so right from the beginning of the graph to 2010. So 1900 to 2010. California had a bigger, it rose faster. I guess that makes sense because look at California started out at maybe 2 million and now we're way up at here at like 38 million, right? So from 2 million to 38 million means it went up 36 million. In that same amount of time, Texas went from like, I don't know, maybe 3 or 4 million to 25 million. So it went up a lot less in the same amount of time. And that's because Texas didn't grow as fast, right? So we could look at that as the average rate of change for California being higher. I can just tell on my graph, right, that the slope of C is steeper. If I connected California from beginning to end, and then I connected Texas from beginning to end, the California graph is definitely more steep. So I think that would be my explanation here, is that my California graph is more steep. And again, like we're really looking for informal language here. We want to make sure that we like understand with our own thinking how it works. So slope of C is steeper than T. You could say greater, but it's bigger because the line looks steeper. And so again, in this middle column, we're really trying to use descriptive language that makes sense to us. We're not worried about how it sounds. Now, this last entry that we're going to make is probably the most difficult. So think about how our average rate of change, we learned yesterday, was where we subtracted our outputs. So we have the difference in outputs or change in output divided by our change in input. And when we put that in function notation, it was f of b minus f of a over b minus a. So I have to show this for both California and for Texas. So my California rate of change would be c of 2010 minus c of 1900 divided by 2010 minus 1900. And that's going to be greater than my Texas rate of change, which is going to be t of 2010 minus t of 1900 all over 2010 minus 1900. So this is really tricky. I don't know that I would expect you to completely nail this average rate of change, especially on the first day, but I think it's important for us to look at and for us to understand. So if we do it enough, then you'll be able to do it on your own, right? We might just not be there yet. So main ideas for today's notes. Just this idea that we can compare graphs. So we don't have just one graph anymore. We can compare them and we can go through it and we can make all these different statements. So hopefully even on your own you recognized that first the Texas graph was above the California one, that you had the spot where they were the same, that then California was above, and then thinking about those average rates of change. So those are all really good things to look at with graphs, and that we can also express things with function notation. So the function notation is not going away. So as always, if you have questions, please make sure you ask.